Also, dass Wie binden wir denn in die offenen Datenökosysteme auch Lieferketten mit ein? Noch einmal kurz zum Abschluss sprechen über die Plattform
Ladies and gentlemen, welcome to the pulse of global industry. Welcome to the stage where the future takes shape. Here, at the crossroads of innovation and transformation, more than 100 speakers from business, politics, science, and society unite. Where industrial AI becomes reality, where energy systems evolve beyond imagination, where mobility reinvents itself, where security and resilience define our global strength. This is the arena for infinite ideas, for bold strategies, for solutions that ignite real-world impact. Experience industrial transformation, here and now. This stage is where the world's most influential minds confront the challenges of tomorrow. Prepare for inspiration, prepare for disruption, prepare for transformation. This is the international stage for industrial innovation. This is where the future begins.
Well, hello everyone, and a warm welcome to our automotive session here at the center stage of the Hannover Messe. My name is Pascal Nagel. I'm the editor-in-chief for magazines Automobilproduktion, Automotive IT, and Automobilelektronik. And with me is my dear colleague and editor for Automotive Manufacturing Solutions, Timo Gilgen. Hi, Timo.
Hello from my side. Hello, everyone.
Well, ladies and gentlemen, today we are looking at one of the most important and, for sure, one of the most talked about industries at the moment. The automotive sector is being reshaped by climate targets, disrupting technologies, shifting global value chains, and new geopolitical realities, for sure. At the same time, manufacturers and suppliers are under pressure to combine resilience, sustainability, and digital innovation.
Yes, and what is emerging is a new automotive industry, more software-driven, more connected, and more dependent on strong industrial ecosystems, smart regulation, and technological sovereignty. So in this session, we want to discuss the key technological and industrial choices that will determine Europe's automotive industry can remain economically strong, ecologically sustainable, and digitally competitive.
And to explore exactly that, we have three interesting and exciting discussions and presentations prepared for you, with insights from our platinum sponsors AWS and Bain Company, with insights from the likes of Schaeffler, Volkswagen, Siemens, to name just a few. And we have a look behind the scenes of a Formula One team. You don't want to miss that.
That's right, that's right. So let's get started with a conversation about transformation, competitiveness, and the future of automotive in Europe. Dear guests, industrial automation is entering a new phase. For decades, value creation was concentrated in the traditional automotive pyramid. But with AI, software and data platforms becoming more important, that logic is beginning to change. Profit pools are shifting, competitive positions are being redefined, and the question is no longer just about control systems, but about who will own intelligence across the industrial stack. What does this mean for manufacturers, technology providers, and industrial ecosystems? Where will value be created in the future, and which capabilities, partnerships, and strategies will matter most as AI moves deeper into design, production, and operations? To discuss exactly that, our center stage sponsor and one of the leading global management consultancies, Bain Company, has gathered some great experts from Siemens, NVIDIA, Schaeffler, and Cognite. So please welcome on stage Adrian Braun, Michael Schertler, Rainer Brehm, Timo Kistner, John Lervik, and Florian Dörfuß.
Good morning. As we are here at the Automotive Day of this year's Hannover Messe, let me talk to you about the story of a car. A car is being driven on the highway in Germany. Of course, it's being driven fast. And during the drive, it picks up a small, low-level anomaly in its braking system. That signal is sent via telemetry to the connected car platform of the manufacturer of the OEM, where the data from other vehicles on the roads is being streamed. And because the manufacturer has linked this platform to its production system very quickly, automatically, it can find out in which factories, on which production lines, and on which assembly cell this brake system had been assembled. It can find out that another 2,000 cars have been produced to the same tolerances, and therefore it can issue preventative warning for the remaining vehicles. But more importantly, it can reduce the tolerance threshold that this braking system is being assembled towards. But if it does that, then the braking system itself needs to be designed slightly differently. The supplier needs to reduce the thickness of the brake pad so it can inform the supplier to adapt the design. And that little issue below driver warning or below malfunction notice that our fast German car picked up on the road has been solved before it becomes a real problem. No, the most remarkable part of this story is that it is actually pretty common. Connected cars have been on the road for years, and closed automation feedback loops that allow such use cases are being deployed at scale, starting with the most safety critical features. But if you step outside automotive, and especially if you step outside production-centric use cases, you will see that the vast majority of automation systems that are powering and enabling our factories have never been designed for that kind of intelligence. So here at the Hannover Messe, we are here to discuss what comes next, to talk about automation systems that create value beyond control, to talk about automation systems that create value beyond the four walls of the factories that they are installed in. And also to talk about automation systems that, with AI, will progressively increase their own autonomy. We are entering a new era of industrial automation, and this is the result of forces on both the demand and the supply side of the market. On the demand side, manufacturers are asking for more and more of these cross-cutting use cases, these closed feedback loops of continuous improvement from operations back to design and forward again. And they do so because their clients, the drivers, you and I, are asking for better convenience of use, for better reliability and safety of our products. But also they do that because they see significant opportunities to improve their own operations, their supply chain management, their ability to do product recall. And on the supply side, what has been traditionally challenging in the industrial world, fragmented data, expensive integration of systems, cybersecurity concerns, all the way to more mundane things such as low connectivity, that is being tackled fast. So we are going to a market where demand will increase and supply will improve. That will create significant innovation and growth in the automation space. And growth will be everywhere, but not evenly distributed. It will be everywhere. A good way to think about growth is to think about the automation value as a percent of the sector value add. In automotive, that number is 20. €20 for 1,000 euro of automotive value add. So if you remember the example of that car, let's say it is a 100,000 car. It's an expensive car, but it was a fast car. So the 100,000 car has 2,000 euro of automation enabled in the car, embedded in the car, and in the factories that were used to produce it. That number of 20 is significantly lower outside of oil and gas and automotive. Those industries are not automated today to the full extent. And if we look forward, we will see the highest growth in the automation market in what we call the hybrid verticals, those industries that combine discrete production methods and process production methods, so flows and things that have lower quantities. This is where the bulk of the growth will come, in addition to automotive and oil and gas, which are at the forefront of automation. And at the core of this new era of automation is a digital loop, the digital thread. And this is a combination of data that combines design data, production data, and operation data, and allows for such cross-cutting use cases. Today, manufacturers that are using such digital loops are seeing significant productivity gains, both in innovation cycles, as well as in industrialization processes and in their shop floor productivity. And with AI, this digital thread or digital loop will further increase its value and its autonomy. But we are at the onset of an autonomous automation world. And the main reason for that is that our data is still too fragmented and not accessible enough. And I'll explain what I mean, because data is not data. In an industrial world, we have local data model. Think about a product data model, an equipment data model, and a process data model. Those can be combined. And then we have a digital twin. We can even call it an end-to-end digital twin. But for production-grade, AI-ready data, we need to contextualize this digital twin in the environment in which it operates, in the real-world environment in which it operates. And companies are developing contextual data model, but they're still rather isolated and not deployed at scale. So what the industry is working towards is what we would call a factory world model, or a more comprehensive representation of what happens in which environment and what is the relationship between a digital product and its contextual world. And when AI will have access to that kind of data, everything will change. The potential will increase. AI will become physical. Now, even before those factory world models are being deployed or will be deployed at scale, AI is already significantly impacting the industrial automation landscape. We asked 100 executives about where AI will have the biggest impact on the automation stack and market. And as you see on this chart, the answer is very heterogeneous. We have use cases in the top right territory, where AI will drive significant growth, but also significant substitution of current ways of working and technologies. Think about use cases such as visual detection or production scheduling in the S&OP process. And we also have use cases at the bottom left, such as the blue bot behind me, line calibration, line commissioning. Those will be more resilient. Overall, we expect by 2030, about half of the automation market to rely on AI-enabled offerings, which is significantly faster than most manufacturers currently expect and plan for. So let me take this together, because the shifts that we are talking about are not only about technology. They are about where value is created and captured in the automation market. And a good way to think about that in the past has been along this automation pyramid, right? This is how you and I learned it at school. Most of the value of automation was at the bottom of this pyramid. In the field layer, the machines with their embedded sensors and actuators that were orchestrated with the control systems across the production lines. Today, that pyramid has already become a stack, which means equal importance of enterprise software, operation software, control, and field devices. And as we look forward, this pyramid in its value shape will more look like an hourglass, which means that value will be created at the top on software, data, and AI-enabled workflows, as well as at the bottom in smarter field devices performing edge automation. And in the middle, the traditional PLCs and DCS are being pressured because a lot of their functionalities will migrate to the top or the bottom of this hourglass. Now, the implication for the market is significant. The sum of the profit of the automation industry is across verticals and sectors is about 30 billion. This is the profit pool, if you want, the sum of profit of all the exhibitors of the HANNOVER MESSE plus the few ones that are not here. This is distributed in 50% field, but the king spot of industrial automation has been historically the control, because of the large installed base of that technology and all of the services and upgrades that are wrapped around this. And as we look towards 2030, we expect further bifurcation in the field, smarter, connected IoT endpoints, sensors, further commoditization in the traditional hardware, growth in, on the right, operation software and IoT-enabled solution, growth in specialization, and as you see, pressure in the middle on controls. So what does that mean for different players, for different participants in industrial automation? First, system integrators will really continue the development from custom engineering houses to more data workflow orchestrators. They will consolidate, they will increase their technology intensity, they will specialize. Hyperscalers see that industrial space as a fantastic opportunity to deploy their compute and data infrastructure at the service of industrial and physical AI. Incumbents, automation vendors are really continuing to develop towards cloud-to-edge platform providers, and then also over time, we will discuss this, will increase their interoperability. And maybe the most important implication of all for manufacturers, those really need to design and own the blueprint of autonomous operation. And here we are not talking only about technology choices, we are talking about how the full system fits together from cloud to edge and from design to operation. So let me close by saying two things. First, industrial automation is entering a new era. And that era is about more than industrial automation. This is really about autonomous operation. And to discuss more what vendors and manufacturers must do in that march towards autonomous operation, we have assembled that panel here that my colleague Michael Schertler will now introduce. Thank you.
Thank you very much, Adrian. Thank you for walking us through the structural changes that are reshaping industrial automation. But the real question is, what does this all practically mean? What does it mean for companies building these systems, deploying these systems, and actually operating them on a day-to-day basis? And to explore these questions, I'm delighted to introduce our panelists, 4 leaders from different parts of the ecosystem, all bringing a very distinct perspective to these questions. To the right, Rainer Brehm from Siemens. He's the COO of the automation business and the CTO of Digital Industries. He spent his entire career in the industrial automation pyramid, and he's now shaping the software offering, the top of the hourglass at Siemens. Rainer brings the perspective of a leading automation technology player. Then we have Timo Kistner. Timo leads NVIDIA's manufacturing and industrial AI business, and he's at the forefront of bringing industrial AI to the factories and the plants at the manufacturers. He expects that accelerated computing physical AI and digital twins will become the foundation on which every factory will run in the future. Timo brings a view on the full AI stack, on the AI infrastructure, and is also expanding and partly investing in vertical applications. Then we have John Lervik. John is the co-founder of Cognite. In his experience, the bottleneck to unlock value is not the algorithm, it's actually the data foundation that also Adrian just talked about. Contextualizing industrial data, using it at scale for AI is a critical hurdle to overcome in order to achieve real and measurable benefits. John brings the view of a data operations platform perspective. And finally, we have Florian Dörfus. Florian is from Schaeffler. He leads technology at Schaeffler's special machinery unit. And this is where the next generation of automation systems at Schaeffler is built. And this spans from AI-assisted robot cells to digital twins. And he works where the smart edge basically meets the software layer in the stack. Florian brings a great perspective of an industrial manufacturer who not only pilots but also scales in industrial AI. But let's get into the first topic with this great panel. And that's about the shift in value and the change in control points. Industrial automation has always been about controlling machines, controlling equipment. But this is now changing because it's much more about orchestrating intelligence across the entire life cycle. And this has implications where you capture value and where you actually achieve a competitive position along the stack. My first question goes to you, John, because your thesis is that AI only really scales if we solve topics like data fabric, knowledge graph, etc. From your perspective, as more and more platforms are embedding AI, how do you see the role of an independent data layer? And is that something that is an important strategic control point from your perspective?
Yeah, I think first of all, it's very clear that even before generative AI, being able to manage industrial data properly was key. We saw the 300% to 400% increase in ROI for digital programs by having a proper industrial data foundation. Now, with generative AI, it's even more extreme. Without properly managed data, there's no scaled industrial AI across factories, for example. And I think it's also it's very interesting to see that just in the last year or so, it's now a common understanding that you need to manage your data in a graph, in a knowledge graph. So that's sort of become a common. I was just in Asia last week, Korea, Japan, everywhere. That's a common understanding. The question, though, is how do you actually implement that in practice? And I think it's a common misunderstanding is that it's sufficient just to have a graph. You also need to be able to, of course, to contextualize the data into the graph, but even more importantly, a lot of people rely on federated architectures, and then you will not get the performance and latency that we need to drive operational applications towards autonomous industry. And of course, all of this also needs to work across systems, across equipment, across the value chain, as was explained here as well.
Yeah. Thank you, John. Rainer, from your experience and view, you described this as a shift of automating automation, right? By using software, using digital twins, AI agents, etc. What's your perspective on what the decisive control points are in this stack, right? Is it orchestration of these different elements? Is it the digital thread that you're working on? Or is it the process or domain know-how?
I think there are different topics. So first of all, I like that you catch the digital thread. That's also how we describe it. At the end, there are workflows we need to automate. And we see Siemens working, connecting the digital and the real world. That means coming from product design, production design, and then going into real operations. So we need to connect that. And there's a huge value of making this workflows more automated. In the future, probably more with agents than with manual handover between those workflows, sitting on a data aspect, as John mentioned. In this time, it's more kind of a PLM data backbone, where I think this is positioned, I think, number one. Number two, if we talk about automation, it's not about on the workflow only, it's how we can make automation smarter. Because currently, you say that the profit pool of a classical PLC might shrink. I think the profit pool of a rule-based automation shrinks because you are not flexible enough to adapt to needs which come in the factory. I think AI will go into the control as software, and that's what we work with NVIDIA. We call it physical AI. And then you move from a rule-based to a goal-based automation. So you tell the automation system what you need to do. Grab this glass and put it there. And you don't write a line of code because the system is smart enough. And I think this is a very important aspect which will enhance the automation control as you see it today.
Would be great to get also your perspective, Timo, as you span the full AI stack. I think you also have a view that accelerate computing specifically will change what is actually possible in industrial AI. How do you see this?
Absolutely. So first of all, what is it that we talk about when we talk about the full AI stack and accelerated compute? So when we think about accelerated compute, this is not just a couple of GPUs or a couple of server infrastructure that actually accelerates our workloads. It's a stack including all the frameworks, all the libraries that you need to accelerate those workloads. And in my mind, it's really, if you look across the value chain of an industrial company, every steps in that value chain, everything will be automated and accelerated at one point in time. Automated from a perspective of agentic AI that will tap into that, but specifically accelerated. Think of simulation workloads in the R&D space, like fluid dynamics simulations, tools like StarCCM Plus from Siemens today. They are accelerated with those GPUs. We had those simulations running for days, for weeks. Today, we can run those workloads in hours, if not less. And so next step would then be, think of the production side. Every kind of computer vision model, video search and summarization, industrial AI agents on the shop floor, everything will be automated. Physical AI, Rainer, you mentioned it. We need to simulate that. We need to have simulation capabilities to really have a physics-based representation in which we then can train and simulate the AI models that will then ultimately be deployed on the shop floor. And so literally, from our perspective, what we see in the future, we're going to have a fully accelerated value chain, all the workloads accelerated, everything simulated in the end.
Thank you. I think that raises a good point, and I think you could see this from these different answers. We clearly witnessing how value is moving towards software, moving towards AI and the smart edge. And that always has raised kind of a key question in the industry that has been debated very often, is around what is the winning formula? Is it open ecosystems? Is it more integrated platforms? Or is it actually vertical solution stacks that say are most competitive? And our research shows that we believe that about 60% of the incremental growth and value coming until 2030, that Adrian also showed, will come from vertical specific offerings. But that requires to build ecosystems and to work with partners. And the question always is, where do you compete and where do you collaborate in these constellations? And just because you have already started, Timo, on that, you know, NVIDIA is a company that has built deep partnerships, right, with automation vendors, with data platforms, and with manufacturers. How do you see your role in that stack and in this ecosystem? And what's important in the context of physical AI?
Let me take exactly that, physical AI, in terms of the way we think of physical AI. So first of all, what we have in mind is, like we called it, 3-computer model, 3 areas that we actually need to cover. And I touched upon them before. We need to have the AI training ground to actually train the AI model, the physical AI model that we ultimately want to deploy on the shop floor. We need to simulate that in a physics-based environment, because ultimately today, we don't want to deploy an AI model after we trained it on a robot and just see if it works or not. No, we want to simulate it because today we have the simulation capabilities and the capacity in terms of compute that we can simulate it to an extent that we can really find out how does that model behave. And so the last step, of course, once we have that circle and cycle complete between training and simulation, then we need to deploy that. And this is our 3rd computer. And this is where those partnerships become so relevant. Because if you think about it, AI training, well, what do we need? Well, we first of all need to have the understanding, we need to have the data context. And this is why we need to partner, for example, with companies like Siemens, as well as the end user, to really enable that training. Simulation. Well, again, we need to leverage the know-how that the industrial automation players, that the data platform and contextualization layer bring, and need to combine all of these partners. And last but not least, of course, when it comes to the deployment, mentioned it, physics-based digital twin, well, that doesn't work without us collaborating very closely on the shop floor and literally put all of that into the physics-based representation of what's happening on the shop floor.
That raises for me a question for you, Rainer, because based on what Timo just said is, you as Siemens are basically have always been in strong, let's say control of the control layer, and you've now investing especially in software and have made quite some bold acquisitions. And I have two questions to you. How do you keep the stack still open for partners? And how do you prioritize on where you invest in further verticalization?
Well, first of all, I also believe in the openness. And Siemens just launched Siemens Accelerator, which is easy, open, flexible. So easy and open and flexible is kind of the key of it. And we also, I think the topic of proprietary field buses is over. I think we need to work with IT standards, which we need to adapt to the industrial world. Like our industrial edge is a Docker-based thing. We incorporate the GPUs from NVIDIA to make it accessible for partners. And we're using this stack by ourselves. So we deploy workload like a virtual PLC, but we also invite partners to deploy Docker container apps, which are running in a very safe and secure and deterministic environment on the shop floor. So I think we need to play this entire ecosystem. And we also enable, for example, to ingest data from an edge into Cognite when you want to ingest real-time data in there. So I think we need to be open under this aspect, number one. Number two, where we deploy, I think we deploy where, at the end, where the biggest, or kind of invest where the biggest return of invest is, where the main topic. Kind of going into areas where a lot of manual work is today is an interesting area. That's the reason we look at physical AI, because that's going to be a lever. Our acquisitions around Altair and Dotmatics was the digital twin, the comprehensive digital twin is an enabler to doing all that we have to discuss. And Altair is very strong in that topic. And Dotmatics is very strong on the pharmaceutical side, where also I think we have a big impact. So we're looking where is the biggest need from a customer perspective to fulfill this comprehensive digital twin.
Very interesting. Let's move a bit into, let's say, the actual deployment of AI and what that actually means. We have seen many manufacturers investing quite heavily in automation technologies, and many have gone through investments in Industry 4.0. They have been investing in connectivity. They upgraded their OT architectures. And some are hesitant to say, okay, now is the next wave of technology coming. Why should I really now invest again, or do I wait? And I think it's important there to understand what is really delivering results and adding, let's say, to the value generation opportunity, and what really scales. And I think, Rainer, we discussed in one of our pre-discussions, you said, people will not just rip out everything they just invested in order to deploy AI, right? So it has to be a way that works in a brownfield environment. And it would be great if you share some learnings and say what in a brownfield setting can drive adoption, and what are some learnings to still get it to work.
Well, as I said, you need to be open to adapt, to connect to the most topics, and you need to use standards. So, for example, when we do industrial edge, you can connect to a Rockwell PLC. It talks Ethernet IP, even fast Ethernet IP. It talks Modbus. It talks all different field buses. And then you have data layers where we use DDS, MQTT, which basically connects maybe in northbound. And we work with AWS to have a direct app from AWS, which can ingest data in the cloud. The same with Microsoft, using the stack from NVIDIA. So I think we need to combine it. I think our value add comes when those technology hit the shop floor, because then it need to be reliable, and 80% is not enough to deploy it in a machine. It need to be easy to use for those customers which are not tech experts. It need to be safe, and it need to be in a certain aspect also having a return of invest, because great technologies are good, but it need to get a return of invest. And this is what we're working on to make this happen for the shop floor.
Yeah, I think that's a perfect segue to you, Florian, because you are actually one of the leading companies that are, deploying this in brownfield settings. And it would be great if you share a bit, what has scaled within factories, what has scaled across factories on the AI side. What has been the arguments and business cases that convinced your leadership to make the investment decision?
So basically, that's what Rainer already said. Yeah? In the end, all solutions which are implemented have to show a real value add after a certain period of time. Of course, you have an ramping up period, yeah, which is accepted by everyone. But in the end, a plant manager needs numbers, improved numbers by better solutions. If it's AI or automation solutions, doesn't matter in that case. And these solutions need also to be reliable in the daily production. Yeah, that's really a topic that the people are accepting the technology, the new technology, and then it's getting a sustainable implementation. Yeah? If there's there are already problems, huge problems with the implementation of a technology, then it's always getting a difficult business case. Also because we are talking about brownfield applications, so we are talking about running machines which are producing parts, which are generating money. And the downtime of these machines definitely has also to be considered when implementing these solutions. So to sum it up, it should be a reliable solution which is easy to implement and be accepted by the people, means also easy to use.
Yeah, maybe a comment on the scalability, because my claim is that without scalability, it's not possible to have positive ROI on digitalization, basically.
Correct.
And there is scalability across being able to automate more and more workflows for a given plant, and then scalability across plants as well. And of course, what has changed now with generative AI is that we can automate workflows in a matter of hours instead of months and years when we have to develop conventional software applications. So the question is, how can we then scale those automated workflows efficiently across the plants and across the value chain? And this is again back to the data foundation. If you can't ground the automated AI-powered workflows in trustworthy data, there's no way you can scale.
Yeah. I want to get to our last topic, and this is around AI adoption in the industrial space. I think we heard about it requires interoperability, it requires interfaces, it requires also within companies the right governance for this, cybersecurity, and an architecture that works across the different vendors and allows to create a business case that actually works on the shop floor in the physical environment. So from your perspective, when we discuss a bit, what do vendors, manufacturers, what needs to happen to make the deployment even faster, even safer, and more scalable to have more of these success stories? And I want to start with you, Florian. Maybe you can share also a bit and say, what are some of the burdens that you experienced when you integrated this on the shop floor and when you had to connect vendors and different technologies to make it work? And if you would have a wish, what would it be that you say, what should vendors standardize? What should they simplify? What would help to accelerate?
First of all, I would say the biggest problem we are currently facing is the very heterogeneous quality of data. That's difficult to handle, and that's also difficult to process either by AI or by software tools in general. So what would be a good baseline for me is when everyone could align on a same or at least similar data foundation where it could access to, then we can provide the data in this style, yeah, just naming or labeling or whatever, and then we can create a process chain which can access on this data pool from end to end. So it means from the I always say from the first idea to the finished product, even during production. Yeah? So also we have a digital twin of the running machine, which is already implemented in a facility, which can be fed with real data, and then we can improve it with our simulation model during the operation. Yeah? Then we don't need to stop the operational production, for example. We don't need to have downtime. We can just simulate what process parameters we can improve to make the machine run faster, have less failed parts, and so on and so forth. So that's I think something which would help a lot to have this database to do all these steps. I think we all here agree what's necessary to be done. It's just difficult to get it out of the heritage data we are having.
Timo, you made the point and said, physical AI raises also the demands when it comes to safety, certification, and you need actually a lot of real-world generated data to get models safe and reliable. Now, that data often does not exist, and so you can work with synthetic data, with simulations. What do you think is possible and needed to, let's say, close the gap between these model-trained simulations and the performance in the real world?
So today we reached actually exactly that point where we can close that gap. I mean, think of a safety-relevant use case. Do we want to reproduce something safety-critical just for the sake of getting all the data from a real-world situation? Obviously not. We don't want to try that out. We don't want to destroy any of our machines or bring someone into a critical situation. So obviously we want to have data that we cannot even collect in such a high amount because it's just not existing. So this is exactly where world foundation models come into the play. Foundation models that actually understand the physics around us and that we can leverage to synthesize the data that we need. Hundreds, thousands, millions of different scenarios that then are the input again for all those physics-based simulation environments. So I think that's from our perspective really critical that everyone who is in that situation today and thinks about like, okay, wait a second, how do I get there? I don't even have enough data. Well, the tools are there. You can synthesize the data to an extent that you can really be sure it still represents the actual behavior in the real world.
And Rainer, coming back to you, as you really span the full stack from the OT side to the software side, where do you see misconceptions about these new technologies coming together that slow down adoption? And what would it be where you say people should think about differently in order to, let's say, accelerate and adopt AI in the industrial space faster?
I mean, one aspect, and just I want to build on Florian's topic. I'm also heading the automation topic in the ZVOE, this is German Association for Electrical Industry. And 14 years ago, we founded something called Industry 4.0, and we moved it further, and we have something called Asset Administration Shell. So a lot of topics, what Florian said, there are standard data formats which are very suited to execute on what just was mentioned. I think we need to simply implement it across industries. And I think there a lot of basis is there, but we need to get now into the going, and not only from a concept perspective, from an implementation perspective. I think that's a big topic we need to do. And then basically, I think we will come in this direction as we have discussed, and especially around what's necessary, really bring it down to the topic of the reliability, the ease of use, what I already mentioned.
John, your idea or wish to, let's say, think about what could be done to further drive adoption and acceleration from the perspective of the data view?
No, I mean, we all share the perspective we want to drive towards autonomous industry. And that means we need to be able to close the loop, if you will, in how we operate. And that also means we need to have trust in the data layer. We need to have performance in the data layer. And I think, as Florian said, we also need, to get to that, we need more common industry standards on data modeling, on how you represent data as well. That also, of course, can plug into, physics-based or foundation, industrial foundation models. So that's really my hope, is a more unified industrial movement to leverage AI to move us much quicker towards autonomous industry.
Thank you. I think it is becoming very clear and obvious that industrial automation is entering a new phase, a very exciting phase where factories become adaptive systems that sense, learn, and act across the value chain, and where intelligence is used across the full life cycle. Now, productivity gains, and we see this in many pilots and situations already, they are real and they can scale. But it requires to invest in the right layers. It requires to build the right ecosystem that very often a single company cannot fulfill, but it needs to be orchestrated. We believe companies that move now, that move first, will be the ones that shape the rules of this area and that will reap the benefits out of that trend. With that, a big thank you to the panelists, to Rainer from Siemens, to Timo from NVIDIA, to John from Cognite, and Florian from Schaeffler. and very much looking forward to keeping in touch and observing how we together shape the next era of industrial automation. Thank you.
Thank you.
For those of you who still have appetite to go deeper, we have a dedicated deep dive session starting right now. There are still a few seats available, and very much looking forward to seeing you there. Thank you.
Just in time. Thank you. Thank you very much.
So, thank you very much to all our speakers for the insightful discussion. Well, ladies and gentlemen, what we have seen is that the future of industrial value creation will be shaped by